These projects are designed to cultivate multiple skill sets that complement a series of videos created for the purpose of acquiring a foundational knowledge of the Python programming language. These projects will cover coding both console-based and GUI applications. Tkinter is a Python binding to the tk GUI toolkit, and its framework is built into Python's standard library, so it does not require the installation of any additional modules. This makes Tkinter a convenient choice for building graphical interfaces for Python applications. All source code in these videos is available at the 1byte@a-time GitHub repository. You will find a link to the code used in each video beneath it, in its description and comments section. You may use these links to download the source code.
This is one of our first Tkinter GUI projects in Python. And we're going to use sound and media with several of the projects we're going to work on. So a very convenient module that we can use is playsound, but you won't have it by default. When you first, if you're using Anaconda 3 like I am, and let's see what Python version I am right now. All right, 397. So, you know, in this instance, you're going to need to pip this module in and install it, but that's really easy as long as you have an internet connection. And you don't want to do the default module. If I just did pip install playsound, I'd get the latest, greatest playsound module, which actually doesn't work that well. I've had a lot of bugs and issues with it. So what I recommend instead is install the older version 1.2.2, and you won't have any issues with it. So let's go ahead and install that module. And if you don't receive any errors, then you should be all set. And then we're just gonna close down Visual Studio and reopen it. Okay, and now notice that it finds that module. Okay, so let's run our app and see what it does. And all right, and so we have just a coin tossing app. There's one button for the end user to interact with. If they click toss, it generates a random number between 0 and 1, and based on that, either it displays a tails JPEG or a heads JPEG, and it counts. There's an accumulator that just counts how many tails, how many heads. So random number generator, let's just go through a couple of random sequences here. And it plays the sound using playsound. Okay, that's all it does. Very simple app. All right, and I had it display here as well. And just display the output here. So let's go through this code on this project here. And for a lot of our Tkinter apps, we're going to build our graphical interface inside of a class. And there's a lot of good reasons to do that. As your projects get more complex and larger, you're going to want to organize things inside of classes. And one of the things a lot of people do is they set up their Tkinter graphical interfaces and windows and frames inside of classes. So we'll want to do that. But just to show you that it can be done, the first couple of projects we do with Tkinter, we're not going to set them up inside of a class. We're going to set them up inside of a function. So we have a function here, and this function takes care of our whole graphical interface, and we just invoke it down here and run it. So let's see what happens. First, we need to build the main interface window, and we're going to dynamically size it and have it appear in the middle. And so to do that, we need to get a pointer to an instance of Tkinter. All right, so that's our tk.tk here. Window will act as a pointer to that. These are just a couple of variables to set the width and the height. You can set that to whatever you want. This is going to be the window title, screen width and screen height. We're getting from, in this case right here, window, this instance, right, pointing to Tkinter. There's our toolkit, and these are built-in methods to fetch the screen width and screen height. We don't know. This is dynamic, right? It's going to be different on every end user's computer. We have a variable here up here in the middle. So we're going to take the screen width and subtract the window width, and the screen height and subtract the window height. And we're going to divide by 2 in each. And then basically the idea is just to get it to appear in the middle. So we're doing with that variable. Won't be resizable. You could play with that. You could let the player resize it. But if we're going to use absolute positioning and not relative positioning, you get a lot more control over where things appear when you use absolute positioning. But if that's the case, you may choose to disable resizing the GUI because otherwise it could throw things off in strange places. We're just going to set the background there. So all this is done pointing to Tkinter, an instance, TK is an instance. Okay, we've got 3 images here. These are the 3 JPEGs, right? There's a starting one, coin toss JPEG, the heads JPEG, and the tails JPEG. And this is where we're going to use our image object and image TK. So first we instantiate or build an image object, and we'll get into relative pathing based on the directory where scripts are running in future projects. But right now we're going to keep it simple, and everything's just going to be in the same directory the script is running in, the root directory. So coin toss JPEG, the syntax is we open the graphic file, could be a GIF, could be a JPEG, PNG file. Once we do that, we're going to use the resize method, and anti-alias, and that just it improves the outcome. Sometimes you can get a really distorted image if you use resize. So if you use image.anti-alias, then it can fine-tune that image so it doesn't look so distorted when you resize it. And that's to get it at the proper size, to get all these to be the proper size to fit inside that label. Okay? And we're just doing the same thing here for the heads and the tails. All right, so we set our image objects up, and then these will set in Tkinter widgets. You can set an image property in a label widget, which we'll see, and that can display a graphic, JPEG, GIF. So it works sort of like a picture box in a C++ MFC app or a Java app. Got a couple of globals here: total heads, total tails. Why globals? Well, remember, anything inside of a function, any variable that's declared within that method, that function, when that function ends, it all falls out of scope and that memory is cleared and those values are lost. So if we want to accumulate the value of heads and tails, then we need these to be globals. Why? Because this is a GUI app. All right, graphical programming with a GUI is very different from console programming. In console programming, you can shepherd where the user goes in your app. You can control everything that they do. But when you start using GUIs, they can click an any random sequence and any object on your, any widgets on that GUI, on that frame. So it requires a whole different way of thinking, a different way of coding, a different type of logic, and it's event-based logic. All right, so with widgets and components that go on a frame or window, they can all listen for events, they're triggers, and when it detects that trigger, you specify a method or function called an event handler, and it'll go call that event handler and run that code. And that's what's happening here. So we'll come back to this because this is an event handler, but let's go look at the object that is listening for that trigger. This is what handles the trigger. But let's see how our basic window is set up, okay? So we have a title label, and there are so many different ways to do this. Just like there's 5 or 6 different ways to use globals and declare them, there's 5 or 6 ways to set up widgets on your window, but I'll try to cover different ones in every project. I'll try to use a different way of doing things, and you pick what works best for you. My idea behind that and showing you multiple ways of doing the same thing is that you find the way that you like best. So in this instance, we're gonna make an instance of tk.Label, and then we're going to set the properties afterwards. If we wanted to, and in later projects, you'll see, we could pass these attributes into the constructor and do it all in one line of code if we wanted to. But I like this way because it's really easy to modify and edit different properties, okay? So you can think of all of these in the square brackets as variables, and then these would be the values of those variables as properties. So the text value of the label, the color of the text, the foreground, the color of the background, the justification, the font, the point size. Is it normal? Is it bold? Border width. Do I want a border around my label? Okay, so that's just a basic tk.Label widget. Next, we've got a button. This is really the only item, the only widget on our entire form that's listening for the end user to interact with it. And in this case, it's a tk button. We set the font, Comic Sans MS, 20 points in bold, justify it in the center, background red, foreground white, text toss. Here's an important attribute. You see this one here, command? This is where we tell it where the event handler is. All right, so this button's going to listen now for an event. The event being that button gets clicked, the end user clicks it. Well, what's it going to do when it detects that trigger and here's that event? It's going to go call the event handler button toss command. And it's just a function, but it's unusual in that normally when you call a method or function in Python, you're going to have open and closing parentheses, empty parentheses, but event handlers are special exceptions to that rule. And you don't need empty parentheses to call an event handler, okay? And in this case, we're going to use absolute positioning, so we're going to use place. Takes as argumentation an x coordinate, a y coordinate, a width, and a height. Okay, and we notice we're doing that with all our components all the way down. Okay, so we've got our title label, we've got our button that the player clicks on. We know that it calls that event handler method up above, which we'll look at in just a moment. Okay, so what about this label coin? This is another label, but notice it uses that special image property. And so when our window first loads, this widget is initialized with coin toss image. And that was just the beginning intro image that you saw. We're setting the relief, which you can set border width, justification, background, foreground, and you won't even really see this, but the important thing is this property here, the image property. Next, we have a couple of more labels, number of heads and number of tails, and we're just going to use these to count the number of heads or the number of tails. And then in any Tkinter application, you're always going to have main loop. So our instance of tk, which is window, right, which we set up here. Here's our instance. And then we're going to call main loop on it. So that builds our interface. That's our GUI. That sets up our basic GUI for our coin toss app. Now, what about that event handler? Here's that event handler, button toss command. Let's go take a look at that. This is the function that gets called every time a trigger is detected. It's out there. The button's listening for the end user to click it. When the end user clicks it, it triggers a click event. When it hears click event, it will call the event handler that we designated. So what happens? Well, we have to use our globals, all right? And again, in different projects, we'll look at 4 or 5 different ways of using globals. This is just one way. But one way is we can declare them out here, outside the method, outside the function. But notice we're inside of another function. And here's the thing. This is something you can do in Python, which you can't do in a lot of other languages. You can nest one function or method inside of another. You could even keep going and have multiple levels of nesting, one method or one function inside of another. But that produces issues with scope. You have to imagine where your scope is. So in my app, my real global namespace is way out here outside of any functions. And remember, Python uses indentation to define scope. So this would be actually my global namespace. This is sort of a pseudo global namespace It's global to this event handler function button toss command, but it's local with inside GUI interface. But that's okay. These values will persist as long as main loop down here keeps running on my window. Okay? So the way to scope into these as globals is to use this keyword non-local and then total heads and total tails. Again, I don't want to create local variables inside of this method nested inside of another function because this is going to get called every single time the player clicks the button. And if that's true, then every single time the value of total heads and total tails would be lost. And then they click it again and it would never accumulate. It would never count the value. So to get it to persist, to accumulate the values, we need to make sure that we access a scope outside of this function so that those values persist in memory. You understand? Okay, so here we're using our random object. We're just going to generate a random number between 0 and 1. If flick is 0, well, it's heads. Else, otherwise, if it's not heads, if it's not 0, it's got to be 1. And then, therefore, it's tails. Either way, what do? We'll accumulate. And I just wanted to show you this. How would you accumulate? When you accumulate, you take 1, you increment, like in C++ or Java, you can have a postfix or a prefix increment or decrement. Well, you have something similar in Python. You can do it this way. The variable is equal to the variable plus 1 every time. That way it would accumulate the number of heads tossed or the number of tails tossed. Or you can do it this way, sort of a shorthand way. It means the same thing, okay? It means the exact same thing. So if I say, the addition operator and then the assignment operator, total heads plus equals 1, it's the same as saying total heads is equal to total heads plus 1. Either way, some people prefer this way because it's shorter, maybe more to the point. And then what? We're going to display that, but here's the thing. This is an integer value. If we're going to do math on it, it's got to either be a float or an integer. And we only need whole numbers in this case, so it's going to be an integer. But if it's an integer, and we're going to try to display it in a widget, like a tk.Label, we have to parse it or convert it to a compatible data type. So we have to convert it from an integer to a string. And Python has a great built-in function for that, the str method. You just call str, and in the parentheses as an argument, you pass in the integer or the float that you want to convert, and it'll convert it to a string. And then we have no problem concatenating it together and displaying it in that label. Understand? And so we're just going to display it in the labels on the GUI, and we're also going to print it in the console just for double trouble feedback. And here we're going to play a sound. Either way, whether it's heads or whether it's tails, in this function, this nested method inside of another function, we are going to call playsound. But we don't want to call playsound just by itself. Like I could just say playsound and call that and pass in cointoss.wave and play that sound. But if I did, here's the problem with that. If I don't do this in a separate thread, like I'm doing here, then it's going to execute inside of main loop. And then what will happen is whenever I play the sound, it'll lock up my GUI. And the end user won't be able to click on any widgets or interact with the GUI at all. It'll stay locked up until that sound is finished playing. And whenever you do looping, like we're going to make a network app where we'll do ping sweeping and port scans, and that involves looping. If you don't do that in a separate thread, if you do that repetitive processing inside of main loop, it's going to lock up your GUI every time and it will become unresponsive. So this sort of brings us into threading, but there's a lot more to threading, but all we need to know at this point, we need to import it. And then to use it, it's just going to be threading.thread. And then here we're just calling the method, the playsound method that we get from up here, playsound, import playsound. So this way we're launching it inside of a separate thread. We're going to go play cointoss.wave. All right. We want to start that. We want to start the thread there. And that way not only will our GUI remain responsive, but we can do this. Let's run our app here. Let's run our app here. Okay. Notice I can play one sound before the previous sound has finished. All right, so I can do it asynchronously, which is important. Otherwise, it wouldn't play the sound. And I can keep clicking as much as I want. That's okay because those sounds are in separate threads, and it's counting up here. But if it weren't for multi-threading in this app, if that was to occur inside of main loop, then it would lock up our GUI.